this snap circuits video, this is going to be kind of a continuation on a previous video that I had done recently on repairing and upgrading your snap circuits components. And I kind of go over what components you can upgrade and repair, ones that you potentially can do, but then also the ones that you pretty much can't really do at all. And this sort of stems from a component that I had fail before the start of the last snap circuit video projects that I did, and it's this alarm IC here. I've already taken the back cover off, and this is my newest alarm IC I have that failed. You can see the design of it here. It's basically a circuit board that's directly soldered to the points on there, and I believe I've showed in a previous video that other alarm IC, which is actually the one I'm using now, that has a little circuit board inside of it with wires. So this is not a serviceable component here, as an example, because the main chip again has failed on here. It smells of burnt electronics, it's overheating, shorting directly to ground, and it's not usable. And again, this is my newest one of these because this is the third one for the set here, this SC750, that has failed on me. At least the one I'm using there at least has 2 functional inputs on it, so it still works for the rest of the projects that I'm going to show. But again, this kind of stems from an example here of one that you can't fix. So I've laid all the parts out from the SC750 here on the bench, kind of in groups, to show what we can fix and repair, and again the ones that we potentially can and the ones we just can't do at all. So bring the camera over here to the board. So everything that's on the board here is easily user replaceable and upgradable, and I've already shown it with the lights here, that you can of course take the back covers off of these very easily. And by doing that, you pull the back off and you can easily take out the old burned out bulbs, ream the middle out, and put in one of these little E10 lamp holders with the correct bulb. Again, this is a 3-volt holder, and so is this one. You can certainly do it with the 6-volt holder because this is generally how they look most of the time, with the actual little bulb in there that you can of course clip away and desolder. So we open it up. And that's how basically you would clip the ends of the bulb right there, leave the wires, and just solder an E10 socket in there and ream the center out, and then you can put 6-volt bulb in here. So that's an easy upgrade for this, plus a fix for the 6-volt lamp holder. And of course they just snap back together. The switches are pretty easy to fix as well. Again, a lot of these 3 wide snaps are very easy to open, like so. And with the switch, it's just held in there with 2 little rivets. You can just drill the rivets out, pull the defective switch out, and then resolder a new switch in there of about the same size if this switch fails on you. Push button's a little different. Again, they may have variations on these depending what you get or how it was built from the factory. Like for the push button here, the push button is a 4-pin, so you got 2 pins on one side, 2 pins on the other, and it's connected across a little board here, and then it's soldered. The pins are just folded over, so if you fold the pins back after desoldering, you can pull this little push button switch out and replace this if you so choose. Again, they snap back just like that. For something like the various sensors here, like the photoresistor. Photoresistor again opens up, and this is clear, so we don't really need to take this apart. But again, it's similar to the lamps there. It's just got the leads coming off the actual photoresistor inside there. It has this little black sleeve around it so that there isn't any light leakage from the sides interfering with the reading that the photoresistor is getting. It's just from the very top here. So if you're replacing this, you need to make sure you include this little black sleeve when replacing the photoresistor. And like the photoresistor, it's the same thing with the microphone. You can simply unsnap this desolder the connections from the microphone, or you can even just clip it like the bulb and just pull the little microphone out there and put a new one in. Not that hard to do. Let's see. Interesting one here is the transformer. Because the transformer, although it's got 5 connections on there, it's actually simple to replace for a very basic reason. It's a transformer, so as a transformer, there isn't a lot to it. You simply just got a transformer in there. Let's see if I can pop this open. I'll pop it open from this end. See? It's just a 5-wire transformer in there. So as long as you find the right type of transformer to put in here, you could easily replace one of these. Let's see. The transistors are pretty easy to replace as well, both the NPN and PNP along with our SCR. Again, they're just 3 wires, the base here, your collector, and emitter. And so you just got 3 strands that come like that under there. It's a little tricky to open because you've got 3 snaps here, and a snap there, and a snap here. So it takes a little bit of effort to open. I can't really open it by hand. You have to use a little bit of a tool to get in the snaps there and snap it away. You might break 1 or 2 of the snaps in the process because of how the shape of this is designed. But that's the same for this along with the PNP transistor. Again, the same kind of thing at this collector, emitter, base. And of course, you can do the same for the SCR. So the SCR there, you have the gate and the part there. Again, same thing, 3 leads, so pretty easy. And again, these are a component that's worth upgrading too if you want to try to upgrade some of the components, because the PNP and NPN transistors are basic transistors. I think they only handle 500 milliamps or so. You could beef them up a little bit to handle a higher voltage range, or maybe even bring them up to 1 amp of current that they can work with. So that's one thing you can do. LEDs there. Again, LEDs like the bulbs, pretty simple to replace. See if I can open this one using my fingernail to get in there. There we go. Pull it out, and you see here, this red LED has a resistor wired in with it. You can see where the holes are that it goes through. And the reason the red LED has a resistor on it is because the red LEDs have a lower turn-on voltage than what some other LEDs like the green LED on there do. So that's why they put a resistor in line on this one. So, but of course, you don't have to replace this with a red LED. If you need to replace it or upgrade it, you can put any color LED you want here, or even a bigger LED, like 10 millimeter. This is a 5 millimeter, that's one in here. Or if you want, you can go smaller and put a little 3 millimeter in there. Or one of the odd shaped ones like a rectangle or something like that. So you got some flexibility if you want to replace the stock LED with a different colored LED, or an entirely different kind. And we can look at the green one here, just for the sake of it. Fingernail in there. Takes a little effort, sometimes it's working my fingernail too, because I just recently clipped my fingernails. I don't think I'm going to show this one. There we go, got it. And like the red LED, this one also has a little resistor tied in there as well. And again, they do that for protection too, because you can put these generally directly across the 3-volt battery pack, and they'll work fine. And so that gives it a little extra added protection on the diode. And then this, of course, is our regular D3 diode. Again, this is another potential item that you can upgrade to have more capacity. This one I think I had recently opened up. So, yeah, it's just a standard diode going through there, nothing like an LED, so pretty simple to replace. Just desolder the old one and solder a new one in. And again, you can easily upgrade this with a much larger capacity diode. This diode, I believe, is probably rated for 1 amp max. You probably wouldn't need to really go bigger than that, because usually 3 amps is the next step up for a diode like this. And for the voltage, you probably don't need to worry about that either. So a very basic diode can replace this if you so choose to do so. Oh, let's see. Resistors. Again, they're easily replaceable. Can also be upgraded as well. One thing you'll notice about the capacitors, diodes, and stuff is this faceplate is pretty common across all of them, without the hole cutouts for where things go. So yeah, if you need to replace a resistor, it's just like the diodes. You can simply just desolder the old resistor out and put a new one in. These are basically probably a 1/4 watt to 1/2 watt resistors, so 250 milliwatts to 500 milliwatts. You're certainly not dissipating that much power on the snap circuit system to require a resistor of higher wattage. And again, these are pretty cheap and inexpensive to get in packs to replace these if you so choose. Same across all the rest of these. Look at the capacitors. Again, the capacitors are the same way as the diodes and resistors for replacing them. Again, all these cases open the same way. Back there, of course, this one is snapping shut, so let me try using a different one. It's a little easier to open. A little easier. So here's our 100 microfarad electrolytic. Again, same universal kind of layout, just different color. But again, you can desolder the old capacitor out of it and solder in a new one, just making sure that you have the polarity correct so that the positive side of the cap matches up with the connection over here, so that you don't accidentally put it in backwards. Again, pretty simple to replace, or again, you can upgrade these with even bigger or smaller electrolytics if you so choose. And the same thing applies to these Mylar capacitors. That's what these are. So if you need to replace these, again, it's the same process of opening and desoldering and putting a new one in. These, of course, are not polarized, so it doesn't matter which way you put the capacitor back in there. That pretty much covers it for everything on the board. Again, this is pretty much the easily replaceable and upgradable parts of the snap circuit system. So let's now start looking at some of the other varieties. So for instance, we have all the various snap wires that are used in the snap circuit system. Now generally these don't fail, but the only reason they would fail is the little metal strip inside becoming broken at some point, probably because these were being bent a bunch of time through use or something, or really flexed, and metal fatigue just broke the strip inside. And this is a very simple thing you can replace with just a little bit of solder and some flux where the break is, or if you need to do a big replacement, you can just use some bare wire and solder some wire, but really it'll just be a small break or crack somewhere in the metal strip. And again, solder and flux will easily take care of that. So that's pretty much how it is for any kind of snap wires. So now let's talk about some items that you can potentially repair, but might require a little bit of effort to do. Oh, and I forgot about the snap wires too. The snap wires, as I mentioned, I think in my last video, how this one came off the snap here because the little enclosure part actually broke. So again, you can just solder these directly back on there. A very simple, easy thing to fix. Especially if a wire breaks or something, you can just join the wires back together with some solder and heat shrink, and you can even make these longer if you want to upgrade them to increase their length for whatever reason. So this is snap wires. So anyway, now we have a number of the parts that, in my opinion, you can potentially repair or possibly upgrade, but there's a little more effort involved. Like for the variable capacitor here, this one is actually fairly easy to replace. It just takes a little effort to fix because you do have the wires on the outside, so you don't have to take the snap apart. Just take the screw out of the dial here, and then you've got two screws inside that hold the actual variable capacitor onto the bracket here. And you can just desolder the wires and solder a new one on. The trick will be matching the capacitance rating of this variable capacitor so that it's in the correct range for replacing it if you so choose to do that. Another one here is the high frequency IC. Now this kind of goes along with the variable capacitor because those two components are really only used in the projects that involve building an AM radio. They're not really used in anything else, so fixing them or whatever may not be as big a priority as maybe some other parts, because again, this frequency IC, although it has the 4 connections and is shaped like the transistors, it has a different kind of purpose and function, again specific to use for the AM radio for handling AM radio signals. So there's a little more involved with replacing this. The speaker is also a bit of a tricky one as well. Now the thing with the speakers, they always have a marking on them, so this one is 8 ohms, half watt. So that would tell you the speaker specification right off the bat there if you had to replace the speaker. The catch is opening this up and being able to replace the speaker because you have no snaps on the base here, and you do have some resistors built into the speaker here. So you have a single Phillips screw down here, and then you got 2 snaps at the top, and then you got to be able to pull the back of this off to get access into there. And how much wire you have to work with, or if even the speaker is glued to the inside of this thing, I don't know. So this is one of those parts that you probably could repair or upgrade, but it's one that you might just replace with the same part. The 7-segment LED is another one of those that is probably easy to work on. It's just that it's going to take some effort because you have 1, 2, 3, 4, 5, 6, 7, 8, 9 connections on this thing. So it's 7 segments, so you got 9 connections because you've got your positive inputs, and then you've got your 7 segments plus the decimal point, which is all used with little yellow wires that you might see in there that all connect to the 7th segment. And then it's how it's fixed into the plate that you got to also figure out as well, because if this is bad, you got to be able to get this segment display off of here and be able to put a new one on and then solder all the connections to it. My guess is that they probably have a circuit board inside this that this is soldered to with all the wire connections. I don't think all the wires go to it individually. That's just my guess without opening this up, because again, the other thing is you got to work all these snaps to be able to pull this plate off to be able to work on it. That's the other hang up with these. Same thing applies to the S3 relay here. You've got all the snaps around the base here that you got to work on, and you've got all these connections with the relay here. And this is one of those parts that also, in my opinion, it's probably just worth replacing with the actual snap circuit part instead of trying to repair or replace the actual relay component here, because again, it depends how it's been assembled inside here. Yes, they do have wire connections going to these, but then again, like the 7-segment display, this is probably adhered to a circuit board on the underside of this here, keeping it in place and then having all the connections go to that. And again, too, it's probably not worth trying to replace the individual relay component on here, because especially when you've got all this very thin coil of wire here, which of course is the electromagnet for the relay to work. So this is one of those components that you probably could fix, but it would be very limited on what you could fix on it. So that pretty much covers the segment for potential repair and upgradable parts. So we've already done ones that you can easily fix and repair, ones that you potentially can fix and repair, and now we're going to look at the last segment, which is the ones that you pretty much can't do any upgrades or repairs on, you have to replace. So we'll start with the electromagnet here. And this one's probably pretty obvious. This is nothing but a bunch of thin copper wire spiraled around a spherical pattern there for the core here so that it works as an electromagnet. Again, there is no physical snaps on here. It's completely sealed, so you cannot open this up with any kind of snaps. You would have to destructively open it up, which means actually cutting into the plastic and cutting it away to get in here. So this is a part you cannot service or repair or any kind. The antenna here is another one. Now, even though you can open this up, I would not really want to work on this because this is just like the electromagnet here, because this is an inductor, and what it is you've got a iron core rod inside of there, and then like the electromagnet and the relay, you've got a whole bunch of this very thin wire wrapped around it, and that's what allows it to expand and collapse a magnetic field. That's how an inductor works, is by storing energy in a magnetic field, and that's how this antenna works. So this is the part I would not mess with trying to repair or upgrade. You're better just replacing it. The FM module is a pretty simple reason. It's also probably only used in maybe one project or two, maybe three at the most. This doesn't really have a lot of use in the snap circuits because it's just a FM radio module. 3 connections there for power and output, and other than that there's not really a whole lot you can service on this. You're just gonna have to replace it. Oh, let's see, the solar panel. Again, what could you possibly service on this? Maybe just some wires or something inside that's broken, but if the solar panel itself has failed or is cracked, damaged, or anything, well, you can't really repair it. You probably could replace this with another panel that you find, but you have to decide if it's worth the effort of doing that, because you got to find it, it's got to fit in here, it's got to have the right output voltage rating and all that kind of business, and working all these snaps out, because the snaps on this are different compared to the other ones. They're on the bottom, not the side. So this one, again, you might be able to do something with, but still, again, probably better replacing. The recording IC. Again, the difficulty with these is getting all these snaps off, and you've got 7 connections here on the recording IC, and they all have a lot of different functions. And the board in here, of course, has memory and individual electronic components on there, along with a couple of integrated IC modules and everything that make the recording IC work. So this is one thing, again, that's not really worth trying to work on. You're just going to have to replace the module. The meter here, again, is one I probably don't think you could really do any kind of work on, because, again, with the meter, you've got a needle in there that's a little electromagnet that moves the needle back and forth. You've got a switch here that controls the current capability of the meter, and so it's probably got some resistors and other circuitry in there for that function. And also, this takes a little bit of effort to open as well. So again, probably just wires or whatever, and here's about all you could fix. You really can't fix the meter part of it, I wouldn't think. All the integrated modules. And again, in my opinion, every one of these you can't really fix because they are integrated circuits. They have a circuit board in there with dedicated components. And because of that, I mean, one thing you could try to fix, that one's not going to want to open. Let's do the amplifier, because I had this one open recently. Oh, boy. Looks better to open from this side. So like for the instance of the amplifier IC, and this is what I said is the difference between these older ones and the newer ones that are soldered directly like this. They actually had little wires going to the boards in these. And we take it out, this again is the amplifier integrated circuit, so it's got a dedicated chip on there, it's got a couple of little capacitors on there and other little discrete components there, again used for amplification. You could try to fix these, but if the main chip, which is usually what's going to fail on them, which again is what happened with this, you're not really going to be able to fix them. You have to replace them. And that, again, as I say, pretty much applies across all of these integrated circuits, because they're all going to be like that with little discrete circuit boards in them. And again, this one has its main chip covered in epoxy resin there, along with some discrete components like little resistors and capacitors on there. And like with the alarm IC, this is an older one. As you see, it's very different from the newer one I got here that failed. But again, that's how that one is. As I say, these ICs you're really not going to be able to do any repairs on. Again, this is plates covered up, but again, they're all genuinely the same. So if these fail, and again, as I say, it's usually the main IC that fails in these, you just got to replace them. The variable resistor, this is probably one also that you would probably just replace, because again, it's a variable resistor and it's got certain resistances that you have to specify for the snap circuit system so that it works properly with the projects. So if you're able to find one, you might be able to replace this, but again, you know, this is one of those parts you might just decide to replace. The motor here, the motor could be a replaceable part, but the problem is that the actual enclosure is completely sealed. So it's like the electromagnet, there are no snaps anywhere on here, and the motor is held in with little bars there. The only part you can actually replace is the little 3-point here for the fan blade to attach to. And of course, if your fan blade breaks, well, you got really no choice but to replace that. So if the motor burns out, you have to replace the whole module. You can't open this without opening up destructively and then finding the appropriate voltage motor with the right can size and everything to go in back into this. The whistle chip is another one of those that you can't really work on. So again, there's no snaps on it, even though you see the openings for them. So not much to really say about this. If the whistle chip doesn't work, you gotta just replace the part. The little B6 battery eliminators, if you have these ones, also you really can't do any work on because they have discrete circuitry inside. And I don't really want to open this one up too far because I don't want to break the snaps on the other side there. But there is discrete circuitry inside this for handling voltage regulation and stuff like that. I wonder if the snaps on this one are bad. Oh, wait a minute. This is... that's because that's the other one. Let me see if I can open this one up. That's actually the one I glued closed. That's why that one opens up so easily. This one may not open either. I'm not going to try to force these open. But anyway, you get the idea. There's discrete components in there that do voltage regulation and stuff like that for the various voltage outputs, because the adapter outputs 9 volts, which goes directly in here, and then it steps it down through various conversions and stuff like that to give you the outputs. So that's not something you can really fix yourself. The vibration switch is certainly one of those that I would not mess with at all because of how delicate this part is. This is something that I would suggest you simply just replace, because the vibration switch's purpose is to connect the ends there whenever you vibrate it or it sends a shock or something like that. So the inside of this is very thin wire, kind of like what's in the electromagnet relay and stuff like that. that allows it to make that connection whenever it's moving inside. So I would not bother trying to fix this. This is one I just replaced. And the battery boxes here, unfortunately you can't repair these, and that's because of how they're built. Again, it's like the motor, the whistle chip, and the other things. There is no snaps on here to get the base cover off, because they're relatively simple. You just got the wire for one connection, and you've got your positive temperature coefficient thermistor right here, which is what cuts off the output from the battery pack. If you're drawing too much current from the batteries, this will heat up, and then it will just basically shut the current off if it gets too hot, and you'll have to wait for it to cool down. So if the wire or a connection in here breaks, or that thermistor fails, well, then you're out of luck. You're just going to have to replace the battery box, because there's no way to get to those to fix them. So that pretty much covers all the parts there. Now I know there might be some other things like, well, what about the computer cable for the CI-73? Well, you could just buy another cable. If the wire is damaged or something like that, you could cut away some of the sheathing on here and get some of the newer wire and just resolder the alligator clip to that new wire. You would of course make the cable shorter and stuff, and if you want to be on the safe side, you might just consider replacing the cable. And then if all else fails, the SC750 of course comes with a little spring-loaded snap here. So this allows you to put custom components that you want to test, whether inputs or outputs, onto the snap circuit set there by just putting them into little springs here. So that's basically that. But that is pretty much how we cover. If you want to again work on any of your snap circuits components, that pretty much shows which components you can easily repair and replace, the ones that you potentially can, and then the ones you're just better off replacing from ELENCO there from the manufacturer.